So Bernoulli's theorem for real fluid is V1 by rho g plus V1 square by 2g plus Z1 is equal to V2 by rho g plus V2 square by 2g plus Z2 plus frictional head loss, that is HL. So now next we will go to problem in this chapter. Okay. So I will read the problem. Please follow this problem. So a pipe of diameter 400 mm carries water at a velocity of 25 meter per second. 25 meter per second. Okay. So this is the pipe diameter 400 mm and water carries water at a velocity 25 meter per second. Full stop. The pressure at the point A and B. So there are two ends are there. We have taken two ends. At A point, the pressure is 29.43 Newton per centimeter square, and at B point 22.563 Newton per centimeter square respectively. While the datum head at A and B are 28 meter and 30 meter. Okay. So at the point A it is 28 meter and point B 30 meter. So it is it lies in a inclined manner. Okay. Point A is in lower level, point B is in higher level. Okay. Find the loss of head between A and B. So now consider this is the cross section of the pipe. So this pipe having 400 mm diameter, pressure at A 29.43 Newton per centimeter square, and at ZA, that means datum head. Datum head is 28 meter at the section A. So now at section B, the diameter is same, that is 400 mm, and pressure is 22.583 Newton per centimeter square, and ZB, okay, datum head at B point is 30 meter. Okay, so now what they are asking, find the loss of it between A and B. That means what is HL? Loss of head equal to how much? So this is the question. So we know the Bernoulli's equation for real fluids. So apply that Bernoulli's equation for real fluids, we can easily get the answer. So now write the data given. D is 400 mm, you convert it into meter. That is 0.4 meter. And velocity in the pipe, since the cross section is same, that means the diameter is same throughout the pipe, so velocity also same, that means 25 meter per second, that also given in the question. Next, pressure at A is 29.43 Newton per centimeter square. Next, ZA is 28 meter, velocity 25 meter per second. Now apply the total head or total energy at the point A. So energy at A point is equal to PA by rho G. PA is nothing but, what is PA? Is nothing but pressure at the point A. Next, VA square by 2G plus ZA. So now substitute the values. PA is equal to 29.43 Newton per centimeter square. Rho is 1000 and G is 9.81 plus VA square. VA square is, what is VA? Velocity 25 meter per second. So VA square 25 square. 2G, 2 into 9.81 plus ZA. So what is the datum head at the center of the pipeline at the point A? It is ZA is equal to, what is the ZA given in the question? 28 meter. So it is 28 meter. 28 meter. Okay. So substitute all the values. We get one answer. That is, this is the total head at section A point, at this point. Okay. So it is 89.85 meter. So now we will move to the next one. So here we have to find the total head or total energy at point B. Okay. So now write the equation. EB is equal to, EB is nothing but energy, total energy, equal to PB divided by rho G plus VB square by 2G plus ZB. Okay. So now substitute all the values. What is PB? PV is 22.563 into 10 power 4. Rho means 1000, G is 9.81. Okay, substitute all the values. VB is constant because the cross section is uniform. Okay, so velocity is 25 divided by 2 into 9.81. Next, plus 30. Okay, so what is 30? 30 is the datum head at B point. Datum head at the B point. So substitute all the values, simplify the equation. Finally, we get an answer 84.85. 84.85. So this is the total energy at the point B. So now what is HL? It is the difference between total head or total energy at point A minus total head or total energy at point B. So how this equation came? So now you can see, previously we discussed the equation. Now here you can see, so this is for EA. This is for EA. Okay, EA equal to, this is for EB. Okay, so this equation for EB, total energy at point B, plus HL, plus HL. So suppose I want to only HL means EA minus EB. So that's all. So that is the equation. Okay, so here you can see A minus EB is equal to 5 meter. Okay, 5 meter. So this is the answer. So this is the loss of weight due to friction or frictional head loss. Sometimes it is called the only loss of head, HL. Okay. So first understand the question. So whether they given a real fluid, sometimes they may mention this is the real fluid. Sometimes they may not mention. Okay. So understand the question. So what they are asking, what is the loss of head? Okay. Find the loss of head between the 2 points. Okay. So loss of head means definitely it is the, when loss of head will come only at the real fluid. For ideal fluid, loss of head will not come. For real fluid only, because in ideal fluid viscosity is 0. Okay, so we can't take it into the viscosity in the ideal fluid, but in case of real fluid we have to incorporate the loss of head also, because here viscosity will come. Okay, so first problem it is clear. So now we will move to the second problem. Second problem, I will read the question. Please follow. A pipeline carrying oil of specific gravity 0.87. Okay. So in this problem, they didn't give water. Okay. So they give some oil, say like castor oil or some other oil. So specific gravity is less than 1. So less than 1 means its density less than the water density. Okay. So from this specific gravity, we can easily calculate the density. So 0.87 multiplied by density of water. We can easily get the density of this oil. Okay. So a pipeline carrying oil of specific gravity 0.87. Changes in diameter from 200 mm diameter at a position A to 500 mm diameter at a position B is 4 meter at a higher level. So students, here you can understand there are two different diameter is given. So in the question they given two different diameter means it is like a tapered pipe, a conical pipe. Okay, not an uniform pipe. It is like a tapered pipe. Okay. So at point A, datum line not given. So please understand, please check here. At point A, datum, from the datum, height is not given, but B, from the datum, height is given. It is 4 meter. Okay. So if the pressure at A and B are 9.81 Newton per centimeter square and 5.886 Newton per centimeter square. Okay. So at pressure at A, it is 9.81 Newton per centimeter square. At pressure at B, 5.886 Newton per centimeter square, respectively. And the discharge is 200 liters per second. Okay. So please note down here they given liters, not meter cube per second. Okay. So we can't take directly. So first we have to convert liters into meter cube per second. So what they are asking in the question, determine the loss of weight and the direction of the flow. So we have to calculate the loss of weight and the direction. So in which direction the flow is taken place? So either from A to B or either from B to A. Okay. So this is the question. So now we will check that one. Okay. So there are two questions they asked. Okay. What is the loss of weight as well as direction of the flow? So now what are the data given? Now you can write Q is equal to 200 liters per second. If you convert meter cube per second means divided by 1000. So 0.2 meter cube per second. So now specific gravity of the oil is 0.87. So density is 0.87 into 1000, which is equal to 870 kg per meter cube. Okay. So this density is less than 1000 kg per meter cube. Why I am writing 1000? Because water density is 1000. So it is less than the water density. So now what is now we will check the at section 1. So DA means diameter at the point A. It is 200 mm or 0.2 meter. So now area is 5 by 4 into 0.2 square. It is 0.0314 meter square. Next, PA, pressure at A point, 9.81 Newton per centimeter square. Here they given in terms of centimeter square. We have to convert in terms of Newton per meter square. So 9.81 into 10 power 4 Newton per meter square. Okay. So in the question they will give centimeter or mm. So whatever they given means you must convert into meter or meter square. That because we are dealing in terms of meter only. All the problems, if you take our fluid mechanics subject, for all the problem we are dealing in terms of meter only. Okay. So next, if the datum line is passing through A, this is very important step. So why I am writing this datum line is passing through A sentence means, so if you understand the question, if you see the question, there is no datum height is given for the A point. For the A point. So ZA is equal to 0. I assumed. Okay, this is my assumption. This is not given in the question. So this is the datum line. This datum line is passing through the point A. So this is the center point of the center line and center point of the pipe at section A. So this datum line is passing through the point A. Okay. So ZA is equal to 0. Because datum line is passing through A point. Now what is ZB? So ZB value is given in the question 4 meter. So this is your ZB. Okay. So now VA, we must calculate VA. What is VA? What is the formula for velocity? Discharge divided by area of the pipe. So here we are dealing at section A only at this point. At section A. So now what is VA? Discharge. What is discharge? Discharge is given in the question. We already calculated. It is 0.2. What is area? Area also we calculated. It is 0.0314 meter square. Okay. So it is 6.369 meter per second. 6.369 meter per second. So this is the answer of VA. Okay. So once BA found, we can easily calculate the total energy at point A. Okay. So before that, we need to calculate the at section B. So what is the diameter of section B? It is 500 mm. 500 mm. Also, it is 0.5 meter. Okay. So AB is pi by 4 into dB square. It is 0.1963 meter square. So what is PP? PP is 5.886 into 10 power 4 Newton per meter square. So ZP is equal to 4 meter. ZP is equal to 4 meter. So now what is calculate velocity at the P point? So area at B. Discharge divided by discharge is common. Okay, we as per the continuity equation seen in fluid kinematics, discharge is same. Okay, so discharge same. It is 0.2 divided by AB. That means area at the section B. It is 0.1963. Okay. So finally we get an answer 1.018 meter per second. Okay. So therefore total energy at A is equal to PA divided by rho G plus VA square by 2G plus ZA. Okay. So this is the formula. So substitute all the values. So here ZA is equal to 0. ZA is equal to 0. So PA is 9.81 into 10 power 4. I converted into Newton per meter square. Okay. Divided by rho. See here don't forget, here rho is not 1000. This is not water. So here rho is 870. So multiply by 9.81 plus VA is 6.369 square divided by 2 into 9.81 plus ZA is equal to 0 equal to. So finally we get an answer 13.557 meter. Okay. So next total energy at B is equal to PB divided by rho G plus BB square by 2G plus ZB. So substitute all the values. PP is equal to 5.886 into 10 power 4 divided by rho is, what is rho? 870 and G is 9.81 plus VB. VB is 1.018 square and divided by 2G plus ZB. ZB value, it is given in the question, it is 4 meter. So finally simplify this equation. Finally we get an answer 10.948 meter. 10.948 meter. So from this results, you can understand the total energy or total heat at A point is 13.557. Okay, at B point is 10.948. Now tell me what is the reason? What is the, here at A point is lower level, at B point is in a higher level. Okay, so for that only the total heat is at A point is more, at B point is less. Okay, so this is the, consider this is the pipeline. Sorry, okay, so this is the pipeline. This is the tapper one. Okay, this is the center point. So this is in lower level. This is in higher level. Okay, so now this is 13.557 and this is 10.948. Now tell me what is the difference? So the difference is the loss of head, HL. Okay, difference is the loss of head, HL. So it is 2.609 meter. 2.609 meter. Okay, so next direction of flow. What is the direction of the flow? So since EA is more than EB, so this is more than EB. So hence flow is taking place from A to B. A to B. So here EA value is more compared to EB value. So the flow direction is from A to B, not B to A to B. Okay. So where energy is maximum. So the in that pressure also maximum. You can see here pressure at point A is 9.81, but in case of PB is 5.886. Okay. So from this pressure, we can easily conclude flow is taken place from A to B. The final answer also prove that one. Here 13 point. So if pressure increases, the total head also increases. If pressure decreases, the total head also decreases. Okay. So from this, we can say that the direction of flow is from A to B. So this is the final answer. So two questions they asking what is the direction of flow and what is the loss of head. So for the two question, we can easily answer. So these are the important 10 more questions in the university examination. They will ask. Okay. So it also available in your syllabus. Okay. So I think these two problems. So two problems we seen. One is uniform pipe. For uniform pipe, other one is for tapered pipe. Okay. So for two cases we understand. Okay. So shall we move to the next? This chapter is over. Shall we move to the next chapter? So next chapter. What is the next chapter? Is vortex flow. Vortex flow. So this is the next chapter in fluid dynamics. What is by vortex flow? So vortex flow in our day-to-day life we are seeing. Okay. So where we are seeing this type of vortex flow. Okay. So I will tell in kitchen sink, in bathroom that drain. Okay. So if you see in kitchen sink, when if you put lot of water in the kitchen sink, so in the drain pipe there will be a circular motion is occurs. Okay, definitely you can see this type of flow in kitchen sink. So there will be a circular motion of the flow. So that circular motion of the flow is nothing but the vortex flow. Vortex means circular motion. Okay, so vortex flow is defined as the flow of a fluid along a curved path. Okay, along a curved path. Flow of a fluid along a curved path, or the flow of a rotating mass of fluid is known as a vortex flow. The vortex flow of two pipe is forced vortex and free vortex. Forced vortex and free vortex. What is this forced vortex and free vortex? Forced vortex means if you need some vortex means we have to apply some forces to generate that vortex. To generate that vortex. Free vortex means free vortex they won't need external force. It will create automatically. The vortex is create automatically. So that is called free vortex. Okay. So we will see in deeply. Okay, what is meant by force vortex? What is meant by free vortex? Okay. So now we will see the force vortex. Force vortex flow is defined as that type of flow, type of vortex flow in which some external torque, here external torque means external force. Okay, external rotating force. Okay, external rotating force is called torque. Okay, is required to rotate the fluid mass. Okay, is required to rotate the fluid mass. Example, a vertical cylinder containing liquid which is rotated about its central axis with a constant angular velocity. So I think many of you seen 25-liter water can. Okay, if I want to transfer that water from one container to another container, suppose 125-liter water can is there, full of water is there. I want to transfer that 25 liters or 20 liters water can into another empty water can, another 20 liters water can. What you have to do? Just think. So we have to pour the water into the empty water can. So there are two types of method. There are two methods we have to pour in. Simply we have to tilt the 20 liters of water can into the empty liter. So what you observe? So the water is occupied. The air is occupied the empty space, and the water is flowing in a jumbling manner. Okay, into the 20 liters empty can. This is one method simply. The, it will take time. It will take more time to fill the empty water can. So another method is you first give a circular motion. First apply the external force through your hand. Okay, through your hand. Give one circular motion in the 20 liters of water can. Okay, so around 2 rotation or 3 rotation. After that, you tilt and pour the into the empty water can. What you observe? So the water is flow in a freely motion, and it will take very less time to fill that empty container, empty 20-liter water can, because of the vortex flow. Because of the vortex flow. Okay. So this is for the first example. Next, flow of liquid inside the impeller of a centrifugal pump. Okay. So you know about centrifugal pumps, normally pumps. Okay. So the vortex flow is generated inside the impeller, means blades in the pump. And the third one, flow of water through a runner of the turbine. What is by turbine? I think some of you know about turbine. Turbine is the equipment or a machine used in hydro power plant to generate electricity. Okay, say water is thrown into high pressure in the turbine. Okay, so due to this high pressure, the blades of the turbine is rotated. The entire turbine is rotating. Okay, so the water is strike into the turbine blade into high pressure, and the turbine will be rotated like our cycle dynamo. So if turbine is rotated at high speed, so the turbine is connected with the generator. So in the generate, due to the circular motion, in the generate electricity in that generator. Okay, so in that also this type of flow vortex is occurs. Okay. So next, the tangential velocity of any fluid particles is given by, in post vortex flow, there will be one tangential. That means, what is by tangential velocity means? The flow is taken place in circular motion, that velocity. Okay, so the tangential velocity of any fluid particles is given by V is equal to omega into R. Okay, omega into R. So this W term, that means omega, is equal to angular velocity. Angular velocity. R is equal to radius of fluid particles from the axis of the rotation. Okay, from the, suppose for I need some specific fluid particle velocity, means from the axis of the rotation. Mostly it is center. Axis of the rotation means based on the center point only it will rotate from the axis of the rotation to the fluid particle distance. That is the R value. So this is the formula for the forced vortex tangential velocity. Okay. So next, depth of vortex. Depth of vortex. What is meant by depth of vortex means? Suppose a container is there. Okay. So initially this is the water level. This is the water height. Okay. So after vortex is given means the flow is taken place like this. Flow is taken place like this. So this is called Z. This is called depth of vortex, Z. depth of vortex. Okay, so after rotating, so the flow is taken place like this, rotation, okay, in a high speed. So depth of vortex is equal to, this is the formula, omega square into r square divided by 2g. So omega is nothing but angular velocity, r is the radius of the cylinder. So radius, not diameter, keep it in your mind, this is not diameter. So based on the axis of the rotation, the cylinder radius, this is your r. So this is your omega, that means angular velocity, and g is acceleration due to gravity. Okay, so from using this equation we can easily found this z, that means depth of vortex, depth of vortex. So now you can see in this picture, so a vortex is generated, this is the initial stage. So this is the cylinder, this is the cylinder diameter, this is called D point, cylinder diameter. So here the flow of fluid is rotating, okay, in a circular motion. So initially the vortex is formed, this is the initial state, and then if you again you rotate fastly, means this type of vortex is formed. Again you can rotate a very high speed, means so the vortex is formed at a high depth. So this is your Z value. This is your Z value. So up to this is your Z value. Z. And this also at Z. This is the depth of the vortex. Depth of vortex. Okay, now students. Next come to free vortex. Free vortex in day-to-day life we are seeing in kitchen sink, in our during bath, in the bathroom drain, vortexes occurs. Okay, so we are not giving any external torque. Okay, so the vortex is formed automatically. Vortex is formed automatically. So you can see when no external torque is required to rotate the fluid mass, that type of flow is called free vortex. Example, the flow of liquid through a hole provided at the bottom of the container, or provided at the bottom of the sink. Next, the flow of liquid around a circular bend in a pipe. Suppose a pipe is there like this. So this is the circular section. Okay, and this is the pipe. So the flow is taken place like this, means, so this is the circular bend. This is the circular bend. So the flow is taken at the changes its direction. So in this point, the vortex occurs. Next, flow of liquid in a centrifugal pump casing. So here also automatically free vortex occurs in the centrifugal pump. This is the free vortex, and you can see in this picture. So these are all the free vortex best example. Okay, so you can see here in a sea or in a river, a whirlpool in whirlpool is occurred. Whirlpool means there will be a circular motion. Circular motion of the fluid is occurs at some time. Okay, and this is a twister. A cyclone is formed. So there is no force is required. Automatically it formed during rainy season or cyclone season. Okay, and kitchen sink, a free vortex is occur. And this is a Milky Way. This is our universal Milky Way. This is also a free vortex. So these are all the best examples for the free vortex. Okay, so in force vortex, manually or mechanically we have to give some force, but in case of free vortex we don't need the external force, automatically it will occurs. Okay, now student, so from this example you can understand the flow vortex or free vortex. So you can see one of the free vortex, you can see there would be one water bottle is there. So below this water bottle is fully water, and below one empty water bottle is there. So water is the water motion is in a circular motion. Okay, it moves under some angular velocity. Okay, so automatically the water goes to bottom of the container. Okay, in a circular motion. That circular motion is called free vortex. Okay, okay, students. Now we will move to some videos for better understand about the free vortex and forced vortex. Okay.